For this video and for this playlist, I am going to cover recursion in C programming. What is recursion? Recursion is an important concept. It's basically a function that calls itself. There must be a base condition for the recursion because until that base condition is met, the recursion continues. So programmers need to be careful when defining an exit condition from the function. Otherwise, the function will not terminate and the output will be an infinite loop. And what is recursion actually good for? Well, it's frequently used in data structures and algorithm. It's useful for solving mathematical problems like factorials or the Fibonacci series. Basically, any problem that can be solved recursively can also be solved iteratively. And recursion is commonly used in problems such as tree traversals. It may also be applied to sorting, searching, and traversal problems. And what are some of the advantages of recursion? Well, it makes your program elegant. And sometimes the code is a lot shorter when compared to an iterative code. What are some of the disadvantages of recursion? Well, it's not as efficient as some iterative solutions because each function call creates overhead. So it can get very, very expensive as far as space and memory. So if performance is paramount, use loops instead. Recursion code is sometimes difficult to understand and it cannot be applied to all problems. Recursion also involves much complexity in resolving and tracking the values of each recursive call. How does recursion work? Well, a stack is maintained, which tracks the values of each variable at each recursive call. In other words, each recursive call creates a new copy of that method or function in the memory. And since all of the variables and other stuff are declared inside the function, they get stored in the stack. A separate stack frame is maintained every time there is a recursion call. So once data is returned by that function, then that copy of that stack frame is then removed from memory. So in other words, once data is returned from the corresponding function, the stack gets destroyed. To illustrate how a recursive function works, let me go over this example. So on the left-hand side, you can see a main function and a recursive function. Here, I am going to create an activation record for main. And main calls a recursive function, so I'm just going to abbreviate it to RF. So every time a recursive function is called, it creates an activation record. And so we go to this recursive function. If the data is greater than 0, which it is, it's going to call the recursive function again. So this is where the recursion calls. So let me map this out as well. In this case, it is greater than 3, so it's going to call a recursive function again. And in this case, data minus 1, 3 minus 1 will be 2. So this will be RF2. And when this is called, an activation record in the stack is again created. And then we go back here, recursion is called again, and this time data minus 1 will be RF1. And so we're calling this function again. And when we call this function, an activation record is created, RF1. And notice how each of these are greater than 0. So now get to this point again, and it's data minus 1. So now we are RF0. Let me create RF0. And we get here, if data is greater than 0, well, it's not greater than 0, so this terminates. And when it terminates, the activation record is popped from our stack frame. And then we go back here, where it says RF1, well, we have some tasks to do. Here we do the task, and whatever that task is. So do task, after we complete that, this is popped off the stack. So we go to RF2, and there's still do some tasks. So this will do the task, whatever it is. So do task. And after that, it completes the function. So this is terminated. And RF2 is popped off the stack frame. And then we go back to this original function call. And here we do stuff once we get to this line. And after that's done, this is popped off the stack frame. The call then returns to the main function. And let's go over the different types of recursions. There's the head recursions, tail recursions, direct recursions, indirect recursions, and tree recursions. And in this playlist, I am going to cover each recursion and explain what each of them are. So in a nutshell, this is a quick introduction to recursion and how it works.